Hello, thanks for joining us today. We're going to be talking about the reverse chain rule and U substitution. This is the 5th lesson of chapter 5 of unit 5. This is the second to last lesson of the unit. Every question you see today will be a key thing to know for the rest of the year. This video seems like a good time to remind you guys. There's basically an adage in algebra. If you can't solve for x, you'll fail the first semester. If you can't factor, you'll fail the second semester. It's a little antiquated with Common Core, but in calculus it's still true that if you can't differentiate, you would fail this first semester. If you cannot do the reverse chain rule, you will fail the second semester. You will fail the AP test. This is basically half of the course, this lesson, this video. Super important. If you want maximum potency, make sure you are familiar with the second video for 5-4. Make sure you're familiar with lesson 3-3. All right, without further ado. In lesson 3-3, we learned to differentiate composite functions using the general power rule for derivatives, or just the chain rule for power functions. We bring the power down, we keep this the same, and then we differentiate u. Then we differentiate the inside. We're going to reverse this process with integrating. So what we need over here is this part. We would have u to some power n, and that would be the same u over here, and now it would just be one more. This should look very much like you were doing in 5-4, but the main interest for us when we're doing the general power rule, when we're doing the reverse chain rule, is that that guy just kind of disappears. The same way this hooks on, like we talked about, the derivative of the inside hooks on, now this will hook off. It will just disappear when you finish integrating. So if you can locate that, it will just disappear. And that's kind of weird. It's not that bad. You're going to have that factor before you can integrate. It's a crucial part of the reverse chain, which is what we're doing today. So to shake off the dust, let's see this in action. Back in the old days, someone would ask you to differentiate that. In notation, it would look like d by dx of this thingy. And you would be like, okay, I got you. I'll bring down the power. I'll keep this group completely intact. I did not differentiate the inside of the group. I still bring down the power from the outside, and I subtract 1, and I have this hook on. And I think about what's the derivative of the inside. I think about what's the derivative of 1 plus 5x, and that's 5. And that would be a hook on. And we used to label that while we were getting used to it. That's the hook on. It's the derivative of 1 plus 5x. Now, we're going to integrate, let's use the integral symbol, this monstrosity. That's this expressed in symbols. So, I have to look at this and I say, so I need this hook off factor. I need this derivative of u. Deriv of u to be there. Well, what's the derivative of 1 plus 5x? The derivative of 1 plus 5x is still 5. And that 5 is right here. So that hook off. That has to disappear. The same way this has to appear and multiply on, this has to disappear. This has to be there to detach, to die, to sacrifice itself for the cause. And then we can go about our business. And then we can go about our business of keeping the inside the same. I did not integrate. It is not x plus 5x squared over 2. It is just 1 plus 5x. Add 1 to the power. Divide by the new power. Plus c. And that's the final answer. This just goes away. And again, if you have time, which you probably won't on a test, but you will on the homework, you can check. Differentiate. The 4 comes down. It would kill the 4 on the bottom. We would keep the inside the same. We would subtract 1 from the power. And then we would multiply by the derivative of the inside, which is where that 5 came from. Rewatch this part as much times as you need. We're going to go into some examples now. We're going to get our hands real dirty. 3, 2, 1. Okay, so what happens when the hook-off's not there? So when the hook-off's not there, well, we're going to have to make it. Now, how can I make a hook-off up here? So this is like we're missing the hook-off. We're missing the derivative of 3x minus 1. So what's the derivative of 3x minus 1? If you said or thought 3, you're right. Now, the only way to get that 3 in here, right? We need it to look like this, all right? Everything that's the same in red. We really need it to look like this so that that 3 can hook off and go away because it's the derivative of the inside. But I can't just throw a 3 inside because that would be the same as multiplying the whole integral by 3. So now I've gone from something that has a value to something that has 3 times that value. So any kind of creation requires destruction, requires sacrifice. So to create that 3, at the same time, I multiply by 3, I multiply by the reciprocal of 3. I multiply by 3 and I multiply by 1/3. Because 3 times 1/3 is 1. So you're going to multiply by 3 and 1/3 because now all we've done is multiplied by 1. So everything's in balance. Now that 3's here to be hooked off. That 3 is going to disappear. This 1/3 stays. We change the integral sign to a parentheses. Everything is going to get multiplied. Everything is going to get multiplied by 1/3. We keep the inside the same. We're going to add 1 to the power. We're going to divide by the new power. We're going to add c on the end. And there's an answer. Now, again, why do we need this technique? Because the 10th power is too large to expand this whole thing out. You will need this technique in the future. You will learn it now. You must learn this now if you have any hope of finishing the test on time. You have to learn this technique. It's super important. So what we did, one more time, we needed the hook off. In this example, the hook off was already there, so we didn't have to do anything. We just had to unhook it. Here we needed that 3. It wasn't there. So we put that 3 and we multiply it on the outside by its reciprocal. That's it. So turning our attention to number 4. You could FOIL this one out. This one's not as bad. You could FOIL this one out, double distribute, and get something. And then just do power rule. But let's try to be creative. Let's try to be slick. I look at what I have on the inside, and I notice when I stare at this really hard that 3t squared plus 2t is the derivative of t cubed plus t squared. T cubed, the derivative of t cubed is 3t squared. The derivative of 2t is, the derivative of t squared is 2t. So I would say this whole thing is the hook off for, or I'll say it's the hook off. It's the derivative of t cubed, for your notes, plus t squared. So we're going to treat this as a power rule, as a general power rule. Well, what's the power of this group right here? This is t cubed plus t squared to what power? What's the power on the outside? It's 1. So we have the hook off already there. I don't need to multiply by anything. All I need to do is keep the inside the same, add 1 to the power, divide by the new power, plus c. That's it. So we had to increase 1 to the outside power, to the power of the whole group, because I had the derivative of the inside of the group. Please be careful. This one's the trickiest one, I think. You might feel like later ones are trickier. This one's trickier, by far. Okay. 2 more. 2 more in this video. Now, this one gets really tricky. When most students see this one, they panic. They say, I don't know what to do. Well, gee. I wish I saw a group to a power. If I had a group to a power, I could maybe think about hook-offs. You might notice that the bottom is a group to a power. So sometimes we want to rewrite first. This happens a lot. This happens with derivatives. This happens with integrals. So over here, we're going to want to rewrite first. So I'm going to rewrite it as 6x squared times 4x cubed minus 5 to the negative 1/2 power. Make sure you understand why these two things are equal. You want to get to the point where you can see this radical and any radical from here on out as a group to a power. If you can see the radical as a group to a power, you will be 100 times more effective in this course. So, I have a group to a power. The derivative of 4x cubed minus 5 is 12x squared. So I'll make a little note, I think. Need 12x squared hook off. Now, this 6x squared should be a big tip off. You're telling me I need a 12x squared and I already have a 6x squared? Wow, that's convenient. 90% of the time in this class, you will have things like that are that convenient. You need a 12x squared. Well, we have an x squared. We have a 6. How can I make 6x squared into a 12x squared? Leave them one more space. Now, please do not FOIL in. When you have a power in the group, you can't distribute. It drives me crazy. Anyway, so we need a hook off. Well, if I multiply 2 times 6x squared, that whole thing would be the hook off. But again, I can't just multiply by 2. If I multiply by 2, I change the whole value of the integral. So I need to multiply the outside by the reciprocal of 2. Because 2 times 1/2, I really just multiplied by 1. Does that make sense? So that's the hook off. So that 1/2 stays. This whole thing disappears. I needed this to be here so it could sacrifice itself for our success. That 1/2 stays. Change to a parenthesis. Keep that group. Add 1 to the power. Negative 1/2 plus 1 is positive 1/2. We're dividing by 1/2, or I can multiply by 2. It really doesn't matter. I'll write divide by 1/2 in this case. Or 1/2 on the outside. 4x cubed minus 5 to the 1/2 power times 2. You should understand that these are the same. Ideally, you're moving more toward the pink. Because now, especially the 2 times 1/2, it's very nice, right? It's very nice. If you got real crazy, you wanted to simplify all the way, you might notice, just might notice, that you can write it like this. This is very nice. That's very nice because, again, that's something you could take the derivative of and check and see if you can get back to that integral. That'd be good practice for this upcoming test, for the Unit 5 test. Take this derivative, see if you get that, see if you can simplify it all the way down there. All right, one more problem in this video. I feel like it's already getting long. My apologies. All right, over here. All right. So what would the hook off be? Need hook off. The derivative of the inside would be 3y squared. But that's impossible. Exclamation marks. That's impossible. Cannot create y squared. Why can't I create y squared? So I'm going to go off on a tangent about this. This problem is going to have to be done another way. So, right, if I wanted that y squared, oh, I want a 3y squared, so I could do all this, and I would take a 1 over 3y squared. So many students do this. And I tell you every year, I tell everyone every year that this is not okay. But so many students do this. This is not multiplying by 1. This is not multiplying by 1. Because this can't go in. Right? Constants can't factor in and out. Sorry. Constants can. 1/2 can go in and cancel the 2. I did just multiply by 1. So, but y squared can't just go off and on the integral. Powers have to be added. It's all illegal. The reverse chain rule doesn't work. If you need variables. This is an important lesson. This might be more important than all the other examples. Is that this is a tool that it's a really useful tool, but it's a tool that doesn't always work. So we need to master all our other techniques. So since we can't use the reverse chain rule, rewrite instead. Wow. Thanks, pen. You're such a good writer. Rewrite instead with expand. Right. That's the only other option here. Y to the 6 plus 2y cubed plus 1. Not that bad. Not that bad. So understanding the difference between 6 and 5 is the whole course from here on out. I've seen people's hopes and dreams get dashed against the rocks of that. I don't know where that came from. Of not understanding this. You have to understand what the difference is between 6 and 5. Y to the 7th over 7. Add 1 to the power, divide by the power. 2y to the 4th over 4. Add 1 to the power, divide by the power. The antiderivative of 1 in this case is y, because it's dy, because there's all these y's here, plus c. Notice in every example today there's plus c's. Now would be a great time to problem one through 14. If you can't do 1 through 14, you are not ready for this test. I would do 1 through 14 every day. Every day until I understand how to do every single one there. You'd be a master. You would do really well. Find lots of problems. Do those problems. Good luck on those problems. Watch this video again. If you don't understand this video, you will fail. And I'm sorry that sounds so depressing. I hope you all do well. I wish you the best of luck. Talk to me if you need help. You guys have a great day. Have a great night. Talk to you later. Bye-bye.